So a whistle produces sound of frequency of 1 kilohertz. If a listener moves with a speed of 30 meters per second away from the whistle, what frequency does this person hear?
Here's your Doppler
340.
Doppler effect.
equation.
So let's just think about it conceptually.
It's going to get lower and what is it? It's gonna
Lower and softer.
get lower and softer,
Good.
lower and slower, I guess.
Yeah, so if we're moving away, so what's happening is we've got a whistle and it's emitting sound that's traveling out in waves. So if we're just standing there stationary, then those waves are going to hit us at the same rate that they're being produced. But if we're moving away, then that means that from our perspective, it seems like there's more space between each wave than there actually is, because as it's coming towards us, we're walking away.
It's hard, it's trying to catch up to you pretty much.
Exactly. And the opposite is true. If we're walking towards it, then not only are the waves coming towards us, but we're also going towards the sound, so we're hitting these waves faster than they're actually being produced, so we hear a higher pitched sound. So conceptually it makes sense. So we should make a note in our minds, okay, I'm going to do some math here in a second. My answer should come out to be something lower than 1,000 kilohertz.
1,000 hertz.
1,000 hertz, yeah, 1 kilohertz, sorry. So the equation for this, I have to look up because I don't know.
Just called Doppler equation.
Yeah. So there's a couple different Doppler equations, depending on if your sound source is moving away or towards you, or if the person, the observer, is moving away or towards the sound. So we want observer moving away from stationary source. And that equation is F prime equals
F prime.
1 plus velocity of the observer over velocity of the sound. All right. Oh, and then probably multiplied by F. So how does this F differ from this F? What does the prime tell us?
Oh, I forgot.
So just
Prime
the-
is final.
Good. So the normal F, that's what's actually being produced. The prime F is going to be what's actually being experienced. So what it sounds like. So we don't know prime, or frequency prime, so we'll leave that as a variable. 1, so the velocity of our observer, they're moving away at 30 meters per second. So we'd say 30 meters per second. Sound travels, unless told otherwise, at 343 meters per second. And the frequency that's being produced in reality is 1,000 hertz. So we take 30, divide 343, and add that to 1.
343. Did you say 333 or 43?
343. I think I did something wrong because
7? Yeah, that's all right.
oh, it's minus. That's what the problem is.
Oh.
My bad.
So,
So you take 30, divide 343, gives you 0.09-ish. Take 1 and subtract that.
0.9.
That's gives you 0.9125, so on and so forth. Multiply that by 1,000 hertz. So the experienced frequency is going to be 912.5 hertz. which fits our original hypothesis, because we said it's gonna be something lower than 1,000.
912. Yeah, you can do that conceptually on this, but he gives you two 900 answers, one 918, 919, one 912.
Right, so it's just a good way to make a prediction before you do the math. That way you don't just get to the end of your math and you say, oh, that's the answer, without thinking about it.
That's real easy for me to remember though. But that's only for one part though. That's the observer
Yeah, there's
moving away from a source.
like a master version of it where it's like all of them combined into one equation, but I can't remember.
I think he showed us that. and
What
said,
it
"Don't
is.
worry about these, just
Yeah.
use this one." I have the notes for that somewhere.
Yeah, I just don't remember what it is. But yeah, they're all derived from the same concepts, so it makes sense that there's one equation that describes for all situations. You just have to be careful about
Where variables will just cancel out.
exactly and like what goes in as positive, what goes in as negative. And so that's where the specialized versions of the equations are really nice because it does all that for you. But the master equation is nice because then you just have to memorize one thing. You just know how to use it.
Back to this.
Cool, any questions there?
No.